We're standing here in front of the ultimate high-speed cheese slicing line, designed for the company Almikäs. To meet the customer's requirements, we focused on the 𝗛𝗀 9500 in combination with an X-ray scanner and the 𝗛𝗀 5000, including a 𝗛𝗶𝗴𝗵 7000. I'll show you now how all of this works together. At this point, the pre-cut block of Emmental cheese is handed over to our scanner. We use X-ray technology. In other words, this is an X-ray scanner. The primary purpose of this system is to detect foreign objects. But since we obtain information about the product's density at the same time, we can use this data directly and transmit these density values as a so-called scanner table to the slicer, where they are converted per lane into slice thickness. This ensures 100% weight accuracy on the portioning conveyor, lane by lane. This is achieved not only through the scanner, but also through the 4-lane, lane-independent feeding via the Vario grippers. We're working here with 4 separate drives, which convert the scanner data directly into advanced motion, that is, into slice thickness, because slice thickness is the parameter used to regulate the weight. We can't change the number of slices, but we can adjust the slice thickness, and that's controlled here by the Vario drive. Let's take a quick look at the display. We have a 100% good production rate. That means 100% of the packs passing the check weigher are within tolerance and don't require rework. That was one of the customer's requirements. They told us, we only want one operator in the white area. So if nobody has to stand here anymore because the entire process runs fully automatically, then that's a goal that we've achieved very well. Another customer requirement was that we mainly process Swiss-type cheese, Emmental in particular. As everyone knows, Emmental has many holes, and you can't see from the outside where they are. That's a problem when regulating weight, because the hole distribution can't be detected externally with an optical scanning system. That's why we decided to use an X-ray scanner, because it can determine the exact hole distribution based on density values, something optical systems cannot do, since they only capture surface contours. This allows for us to work with giveaway values well below 0.4%, even for Emmentaler applications. After slicing, we have another 4-lane check weigher. It weighs each pack individually, mainly for statistical purposes, to ensure all are within weight limits. We also have an internal feedback system called internal mean value feedback. It continuously measures the average values of all packs and feeds them back to the slicer for fine regulation toward the target weight. The next station in the line is our automatic Infeed system, in this case the 𝗛𝗀 5000. We chose this version because we don't need a cross-lane distribution. We're slicing in 4 lanes and packing in 4 lanes. This means we don't need to distribute lanes onto other lanes. Here we have the grouping conveyor. Essentially, this creates a copy of the format that will later be placed into the packaging. Accordingly, the grouping conveyor arranges these 4 lanes one behind the other, and afterwards the packs are buffered on the buffer conveyors. We've provided 3 buffer conveyors here. The purpose is to bridge the loading time at the slicer, because the slicer needs a certain amount of time to change the product logs, during which no product comes out of the system. To ensure the packaging machine is continuously supplied with material, we use these buffer conveyors. They're designed so that the slicer's loading time can easily be bridged. At this point, we're at the Infeed section. The goal here is to achieve fully automatic operator-free loading. To make this possible, we use a shaking station, so that the portions, which are placed into the film in sync with the packaging machine's cycle, are gently shaken before being placed, ensuring they are positioned cleanly and without touching the sealing seam inside the pack. Here you can see the current cycle speed we're operating at, and as you can see, all parameters, including those of the slicer, can be accessed from here. This is made possible by the 𝗛𝗶𝗴𝗵 One Control operating system. All displays along the line are networked with each other. For the operator, that means there's no need to walk along the entire line to make adjustments. Parameters can be changed from any terminal, and each machine module can be accessed and configured as needed. We work with an adhesive table at the sealing station to enable the fastest possible film change. And we've also provided a second unwinding station for the top film so that the film changes can be carried out as quickly as possible. After the sealing station, we move on to the cross-cutting unit. Here, servo-driven punch units are used, which operate with very low energy consumption and allow precise control of the punch movement at any point. The longitudinal cutting cassette is a special development from our company. It is designed to support the operator so that the cuts can be changed without tools and with minimal time required. That means the operator can replace an entire cassette and quickly restart the machine if the blades need to be changed. After cutting, we move on to the 𝗻𝗠ort. The main task of the 𝗻𝗠ort is to transfer the packs from 4 lanes to a single lane. That means we come out of the packaging machine with 4 lanes, while the subsequent process is single lane, and to ensure this, we use the 𝗻𝗠ort. The 𝗻𝗠ort also has another function. For example, it may happen that an empty pack is produced along the line. There can be various reasons for this. To prevent these empty packs from entering the downstream product flow, they can be ejected here at the 𝗻𝗠ort. And here we reach the metal detection unit. We also have another end-of-line scale from 𝗛𝗶𝗴𝗵 here. The special feature here is that we use the mean value data from this scale to control the slicer once again. You already heard earlier that at the inline control scale, which we use directly behind the slicer, we are already working with internal mean value feedback. And this here is what we call external mean value feedback. Here we have the finished pack completely sealed. We can determine very precisely how the mean value data develops over time and feed this value back to the slicer again so that the average weight can be continuously adjusted to reach the target value.